All right, so we're going to continue on with circle theorems, and we have here cyclic quadrilaterals. So this theorem says that if you can connect 4 points along a circle, so if you look here, we have 1, 2, 3, 4 points connected in creating a quadrilateral, four-sided shape. The angles across from each other are required to be added up so they get 180 degrees. So 70 degrees and 110 is 180, and 180 are 100. Both of them add up to 180 degrees. So this is a cyclic quadrilateral. All right, hard to say a little bit. So let's take a look at this example here, the first one that we have. It should be quite simple. It's just laid out the simple rules. So if I look and I draw a line across from 85 to B, those two should add up to 180, and then A across to 130, and those should add up to 180 as well. So just by inspection, we know that A should be 50 degrees. So 50 degrees plus 130. All right? And now from the second one, we have B, and that should be equal to 180 minus 85. And that will give you 95 degrees. All right, so a very simple one showing the basic rule of cyclic quadrilaterals. Let's see, so part B looks like a fairly straightforward one too. So 88 plus what gives us 180? You can do that simple on your calculator, 180 minus 88, and that gives us 80. That should give us 92 degrees in this case. Okay. For x, well, we know the sum of these two has to add up to 180, so x has to be 90, right? 90 plus 90 is 180. So once again, quite a simple one. All right, for the next one, we have, let's see, well, it looks like we have parallel lines. So if you see two lines like this anywhere in the work or on the test with these two arrows here on one line and two arrows on the other line, these indicate parallel lines, and we can use some tricks with parallel lines. For instance, I can show you one. If I draw a line along here, okay, it's like so, and this line crosses these two parallel lines, you get this angle here is this exact same as this angle here. Okay, so these two angles are the same here. That's the theory of parallel lines. All right, so let's see if we can extend that theory with this question. So what I'm going to do is I'm going to draw a straight line through this here. Okay, and then I'm going to try and extend this line here as close as I can along here. Okay, and finally this line here. So these three lines kind of look like this picture here. So if I drew this line here, that's this first line. I draw this line here, that's the second line, and then I've cut both these two lines here. Okay, so what that helps me figure out is that if this angle is 89, then this angle in here is 89 as well. Okay, 89 degrees. And if this angle in here is 89 degrees, by the other theory that we had looked at in previous videos, if you have crossing lines, the angle that is created between these crosses, sometimes my younger students call them scissors, so these two angles here are equal. So if I have this angle 89 here, across from that K has to equal to 89 just by that rule alone. Okay, so that gives me K, and of course K plus L have to be equal to 180. So L is equal to 180 minus 89, and so that gives us 91 degrees. So we have L and we have K so far. Finally, we can use one of our last tricks here, which is this angle here plus 89 has to equal to this 180 degree line here. So I have 89 degrees here, and if I go 180 minus 89, I get once again 91 degrees in this angle here. And of course, our theorem, the last theorem, or the theorem that we're working with, is J plus 91, these two angles across from each other have to equal to 180. So if that's the case, we've already looked at that. We know that 89 plus 91 is 180, so in this case it's a simple fact that J is equal to 89. Alright, so we have to use a few tricks here, the scissors trick and parallel line, to figure these two out. Alright, for this last one we're looking at, we notice we have this angle 120 degrees, so we can find this angle really easily by using this line here. So one of our tricks, 120 degrees plus something has to be equal to 180. So this line right there, that has to give us 180 degrees. So 120 plus what angle? Well, this little angle here that I have indicated here, this one has to be 60 degrees, doesn't it? 60 plus 120 is 180. So we have this angle here, and this is a little bit of an odd shaped quadrilateral. If you want me to point out the points that are on the circle, we have one corner, two corners, three corners, and four corners. So it is four corners actually. And if I look across from 60 degrees, the corner across from this one here is actually M. So we can find out M easily enough. It should be 180 minus 60, which is 120. Alright, so these are across from each other. Let's call this A and B. Those two are across from each other. So I'm going to call this point C and this last point D. Now, we have something of a scissor effect here, kind of like up here, if you look at this. So if we can find this angle here, we can find our N. And as you can see, we're given the angle across, which is 140. So this point is across exactly from this point. So those two angles have to add up to 180. So let's call this point D. At point D, hold on a second. Once again, at point D, our angle there has to equal to, well, 180 minus 140 is 40 degrees. So we have 40 degrees at this point here. And using the scissor effect, so if this is 40, this would be 40 as well. So that gives us N is equal to 40. Alright, so I have a few more. These are a little bit more complicated ones. Let's start here. So what do we have? Well, I can see two isosceles triangles. Remember, two lines here. So this triangle in the middle here is an isosceles triangle. And because of that, we know that this angle here is the same as this angle here. So this is 64 here. 64. Okay? And what that allows me to do is find out this final angle, because you have three angles in a triangle which have to add up to 180. So if I go 180 minus 64 minus 64, so that's 180 minus 128. So that's going to give me this angle here. I'm going to call this angle capital A. So angle A is equal to, well, let's see, 180, 160, 52 degrees it should be. Okay, So that's A. So we have this angle here. And now, if you look at this shape, you have 1, 2, 3, and 4. So there is our cyclic quadrilateral, and that allows us to look at across from A. The point across from A is this point Y, and using our theory, we know that simply 180 degrees minus 52 degrees should give us this angle here in the corner here, which is our Y. So Y is equal to 180 minus 52, so 130 is equal to 128 degrees here. Okay, so Y, we have Y. Now, if we look at this triangle here, we have this triangle. So if I outline that one, and this one here, so we have this mini triangle, and this is again is an isosceles triangle. So if these two sides are the same, then it must mean that this, whatever this x is, that's the same as this x here, this angle here. Let's put a little x there. All right. So if we have that triangle, then we must know that if we take, for instance, 180 degrees and we subtract y, which is 128, and then we subtract, let's see, well here let's do it a bit different way, let's make it easier. We know that the angle x plus 128 has to equal 280 degrees because it's a triangle. That's our rule. So if I rainbow him over here, we get 180 minus 128, and of course that's 52. And x plus x is 2x. Now if we divide both sides by 2, we finally have our angle here, which is x, and 50 divided by 2 is 26 degrees. So here we have our angle for that one. I'll try number 3, and then you can try number 4 on your own. So let's look at number 3 quickly. Alright, so we have y here, 98 degrees here, x. Well, I already see the mouth-eating rule shown in the previous videos. You can go and look at them if you haven't seen them. And so these two here, these mouths eating the same point off the center. So if this angle is 98 degrees, we can figure out what x is really simple. That's the other theorem, where this angle here is half the size as the middle angle here. Okay, so if we just go 98 divided by 2, that should give us our x value. So that's simple. That's using one of the other theorems. So we get how much? 49 degrees. So that's a quick one. Now how are we going to get y? Well, let's see. I know we can look at the cyclic quadrilateral. If I take this one here, this one here, this one here, and this one here. So if we have a cyclic quadrilateral, that means that this x plus this angle here that they haven't shown, right here, that x and this angle here across from each other has to add up to 180. So if I want to find this angle in here, let's call this angle, say, z, okay? Z is equal to 180 minus this x, which is 49. Okay, and we should get 130, 140, 131 degrees here, if that's the case. Okay, so how does that help us? Well, finally, if we draw a straight line here along this bit here, okay, we know that y plus this angle has to equal to 180 degrees using one of our angle tricks. So that would mean that y is equal to 180 minus this 131 degrees that we just found. And of course we know that it's 49 degrees. So there we have 49 degrees. So using old circle theorems and our tricks, they get more difficult to see, but try number 4 on your own.